Hello everyone. So welcome to the AnalogX. So today we will solve this numerical problem. I posted this numerical on my LinkedIn page AnalogX, and many people there commented. There are many great solutions. So you can go and refer that post. So there are many approaches to solve this numerical problem. So first you can do that simple KCL KVL. Just to apply a KCL here, you will get B out by B input. So now the second approach, we will use some analytic, and then we will solve this. So here we are taking V out here. So by seeing this circuit, we can see that there are two paths, one through M1 and another through M2. Okay. So if I make one block diagram or something, so there are one path and there are two second path, and we are taking one load here across output. Okay. So we can map this as a signal flow. Now we will do here superposition theorem. Okay. So what I will do here, this input is also gain, this one is also gain. Okay. So now I will disconnect this one and I will say this one is gain. Now in case one, I will set this input equal to 0 and I will consider this input. Now this circuit is source degenerated circuit. No. So we are familiar with this circuit. Now, so what will be the gain? In this case, B out by B in will be minus GM into R out. So what will be GM in source degenerated circuit? That will be minus GM1 divided by 1 plus GM1 into SL. Here load is uh, here source resistance is SL. Okay, RS. And what will be R out? R out. If you look up, you will get RL, and if you will see downward, so it is a high impedance, because this transistor will amplify whatever will be here by its intrinsic gate. So the total output impedance will be approximately RL only. Okay. So this is first case. In second case, we will consider this input and we will set this input equal to 0. So this one is, this will be small signal ground, this will be small signal ground. Now we note this circuit is a common gate. Okay, we are applying input as source and taking output as drain, and my gate is ground or common. Okay. So in this case, what will be the output for a simple MOS we are getting if we apply input here V in and take V output here. So this will give 1 plus GM or not. Okay. So now in this case, what will be the output? Here will be V out by V in, and here will be positive. So there is no inversion in this case. So that will be 1 plus GM R naught. So instead of R naught, we will consider here RTH. Okay. So looking from equal impedance. Okay. So what will be the RTH here? RTH will be same. Okay. So that will be RL only. So this is GM2, this is GM2. If I approximate this, so this will be GM2 into RL. So I got two outputs from two inputs. Okay, now I will add both results and I will get total V out by V input. So total V out by V input will be minus GM1 RL divided by 1 plus GM1 SL. Okay, and the this term GM2 RL. So this is my total output. Okay, total transfer function. Now we will analyze further this circuit. Okay, so we got our expression as V out by V input equal to minus Gm1 RL divided by 1 plus Gm1 SL plus Gm2 RL. Okay, so simply we will take LCM, so that will be minus Gm1 RL plus Gm2 RL into 1 plus Gm1 SL divided by 1 plus Gm1 SL. Okay, so now we will open this bracket, so we will get minus Gm1 RL plus Gm2 RL plus Gm1 Gm2 and SL divided by 1 plus Gm1 SL. Okay, so now we will take some common. So minus RL, this will be Gm1 minus, we will take this term as common. So what will be inside? That will be SL into Gm1 Gm2. Okay, so we took this term common. Okay, so that will become this will in denominator. So that will be Gm1 minus Gm2. Okay, now so here there will be RL also. Okay, now the denominator will be 1 plus Gm1 SL. So this is our transfer function. Now if I put Gm1 equal to Gm2 and Gm2 RL equal to 1. Okay, so what will be the result? So if I put here Gm1 equal to 2Gm2. So 2Gm2 minus Gm2 will be Gm1, Gm2, and this Gm2 cancel out this Gm2. Okay, and if I put here Gm equal to 2Gm2, so that will be Gm2, and that will be 1. So what we will get total transfer function as Ts equal to minus of 1 minus SL Gm1 divided by 1 plus SL Gm1. Now see, pole and zero are same in magnitude. Okay, and they are opposite in the quadrant. So this circuit represent a all pass circuit. Okay, so the main purpose of this circuit was to show that this circuit will act like a all pass filter. Okay, so again you can solve you by your own. Okay, so this block will be like minus Gm on divided by 1 plus Gm on SL, and this will be simply Gm. Okay, so you can solve by your own. Okay, and if you see any wrong or you have any doubt in this question, then please comment. I will try to explain or make another video. Okay, okay, and follow this channel. Okay, so now I will post regularly, and in between I was busy, so now I will try to post on regular basis. Okay, thank you, bye.